We're solving problem 11 from the 2023 F equals MA exam. A projectile is thrown from a horizontal surface and reaches a maximum height h, and also lands a distant h from the launch point. Neglecting air resistance, what is the maximum height for a projectile thrown directly upward with the same initial speed? For this problem, we're going to need to use the range and height equations from kinematics. And basically, since it's thrown from a horizontal surface and the distance and height are the same, in this case, r equals h, we can then set these two equations equal to each other. So v squared times sine of 2 theta over g is equal to v squared times sine squared of theta over 2g, where these g's cancel out and the v squares cancel out. We can expand this sine of 2 theta to be equal to 2 sine of theta times cosine of theta. And this is equal to sine squared theta over 2. We can divide both sides by this sine of theta to make this denominator only sine of theta as opposed to sine squared of theta. And then we can divide both sides by cosine of theta and then multiply both sides by 2 to get the tangent force tangent of theta equal to 4. So we have that. That means that we want to solve for the other height because it's launched, thrown with the same initial speed. So it basically wants us to plug this value of in this case, our angle theta into this height equation. This new height is equal to v squared sine, and then the angle is going to be arc tan of 4, and then divided by 2g. This evaluates to 8v squared over 17. And since ideally we want like an equation for the velocity, or we just want equations for all the variables to make things easier. So in this case, the velocity squared is when you multiply the 17 g over, this is a g, multiply it over, so this is 17 gh, and divide it by 8. Now that we have this equation, what we can also do is, since we have the height and we have the velocity, we can now solve for we can solve for the total height, because 1/2 mv squared, or we can use this property that in this case 1/2 mv squared is equal to mg to h prime, or max height, so m's cancel out. And then you want to really isolate, or not isolate, you want to solve for this. So if you put the g on here, this is v squared over 2g is equal to h prime. We want to solve for this so we can plug in the v squared from earlier, and then the g's cancel out from there. So denominator is 17h, and then divided by 2 times 8, because they're both the denominator, is 16. That is our answer for this problem.